Okay, so this is 7.9 Pythagorean identity. And now that we have gotten comfortable with the unit circle, we can introduce this identity, which is basically just like something that is true, an equation that is true. And the identity that we're going to be talking about today is something called the Pythagorean identity. Okay, so we're going to start with this circle over here, and we're going to kind of just review what we learned, right? So if I were to draw a triangle, right, we know that the hypotenuse is 1, right, because this is a unit circle. We also know that this point, whatever it is, the x is cosine of theta, right? Cosine of whatever the reference angle is, so whatever this angle is, and the y is always sine of theta, right? And we learned that, right, if cosine theta is the x, that means that's over here, and sine is the y, so that's over here, right? And so I'm going to redraw this triangle over here so that we can work with it, right? So this was 1, and this is cosine of theta. Here is the angle theta, that's the reference angle, and sine of theta, right? Theta, again, is just any angle. It could be 30, 60, 90, whatever. It could also be radians, right? And what we're going to do is we're going to apply the Pythagorean theorem to this. So if you remember, Pythagorean theorem is a squared plus b squared equals c squared, right? And so I'm going to label this side a, this side b, and this side c, right? And so I have a squared, so instead of a, I'm going to write sine squared. So the way that you usually see this is like this. So sine squared of theta plus cosine squared of theta, right? Because that's what b is, right? That's what I have labeled for b. And for c squared, I have 1 squared. This can be simplified, right? 1 squared is just 1, so I'm going to rewrite the same thing. And this right here is what we call the Pythagorean identity, right? So it's just like an equation that is true. And we can now use this equation almost like a formula, right? We can use it now to find different values. Before we actually apply the Pythagorean identity to a problem, I want to make sure that I want to label this unit circle a little bit more, right? So first of all, I want us to label the quadrants, right? So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I want us to then kind of annotate what is positive and what is negative. So in quadrant 1, both the x and the y are positive. In quadrant 2, the x is negative and the y is positive, right? In quadrant 3, both things are negative, right? Because we're down the bottom left. And over here, the x is positive and the y is negative, right? That's just based on the coordinate plane. And then lastly, I want us to write out the radians for what we call the quadrangle points, right? So we start at 0, and then up here at 90 degrees, that's pi over 2. Then we have pi at 180. Then we have 3 pi over 2 radians. And then if we go a full circle, remember 360 degrees or a full circle is 2 pi radians. Okay? All this info that we wrote down on the unit circle is going to help us with these questions. So let's look at a type of question that you might see. It says, given cosine of theta equals negative 3 over 4, and angle theta is in quadrant 2, what is the exact value of sine of theta in simplest form? Okay, so I have underlined all the key info. So since we're talking about a unit circle, right, it's talking about angles, it's giving us a quadrant. By the way, it's quadrant 2, so I'm going to write down in quadrant 2, according to what we wrote up here, the x is negative and the y is positive, right? And so what we're going to do is, in order to find sine of theta, we're going to use this identity. So I'm just going to copy down the identity, and we're essentially going to use it like a formula, right? So I know what the cosine of theta is. The cosine of theta was given to me. It's negative 3 over 4. So I'm going to rewrite this equation, but substitute in what I know. So I take the cosine and I have to square it, and it equals 1, right? So you can put that in your calculator and you would get, you would get 9/16. And essentially what we want to do is we want to solve for sine, right? So we want to get sine by itself. So I'm first going to subtract by 9/16, right? Because these will cancel out. And then you could put this in your calculator if you wanted to. And so I'm going to get sine squared of theta equals 7/16. And again, I'm looking for sine. I'm not looking for sine squared. So to get rid of the squared, I would just square root, right? And so that's going to give me sine of theta, right? Because all it does is get rid of the square. And then the top, well, I can't simplify square root of 7, but square root of 16 is 4. Now, the only thing that you have to do, and the only thing that can be tricky about these problems, is you need to check the sign, okay? So check the sign. So in this case, we're talking about sine, right? Sine, if you remember, is our y in the coordinate point, right? So if we look at the y is supposed to be positive, right? So we're good to go. This is your correct answer because it should be positive given the fact it's in quadrant 2. Okay, so now we're going to try another problem. So I found what the sine of theta is. It is square root of 7/4. This question says, using the identity of sine squared plus cosine squared equals 1, so that's the identity we just proved, find the value of tan theta to the nearest hundredth if cosine of theta equals 3.5 and the angle, the reference angle is, the angle of rotation is within these 2 radians, okay? So we gotta first deduce, we gotta figure out what quadrant is this. So if I look back up, it's saying the rotation is between 3 pi over 2 and 2 pi. So what quadrant is that? This is quadrant 4. So I'm gonna write that. So this means it's in quadrant 4, and in quadrant 4, the x is positive and the y is negative, okay? So it's telling me to use this formula that we proved. So sine squared of theta plus cosine squared of theta equals 1. And it tells me what cosine of theta is. So I'm going to plug that in. So again, I don't know what sine is. It didn't give it to me, but it did give me what cosine is. So if I simplify, I'm going to get this. And then if you want to, try to pause the video and solve for sine. I'm going to do it here as well. So I'm going to get sine squared of theta equals 0.8775. And then to get rid of the square, I got a square root. So sine of theta. And I'm just going to write down like a few decimals. Okay. And then again, we need to, if you need to write this down again, check the sign. Okay, so in this case, again, whoops, not check the sign, check the sign. Okay, so remember, in a coordinate point, sine is the y. Look here. The y in quadrant 4 should be negative. So that means, I'll do it in red, this needs to be negative. So your answer is negative. But actually, this isn't your answer because it's not asking for sine, it's asking for tan. And if you remember, tan of theta is just sine of theta divided by cosine of theta. And now you have all that information. So sine is negative 0.9367. Cosine was given to you in the problem, 0.35. So if you put that in your calculator, you're going to get negative 2. Well, if you round to the nearest hundredth, that means 2 decimal places, negative 2.68. So tan theta equals negative 2.68. Okay? If you have questions, let us know. Otherwise, move on to the practice.